Hello. Now we're going to look at day 2 for our honors equations. Now, we have an equation here, and the equations we're working with are going to have variables on both sides, mostly. So, my first goal is going to be, since I don't have anything to distribute, and I'm not working with that right now, I'm going to try to get the variables on the same side. So to move this to the other side, what I would need to do is the opposite or inverse. And I'm going to add 4x to each side. What I do on one side of an equation, I must do to the other. This line is just a reminder of the fact there are two sides of an equation, and I need to do the same on each side. So, x plus 4x is 5x. I bring down the minus 3 equals 2. And then negative 4x plus 4x is 0. So I'm not just marking that out, it is a sum of 0. Alright, now I'm going to move the constants to the same side by adding 3 to each side. And that makes 0 here. So I have 5x equals 5. So that's 5 groups of x is 5. So one group of x, going to write it down here, is going to equal 1. Now if I wanted to check this, which you don't have to, but if you want to, you can take your answer and plug it back into the original problem and see if you get the same result on each side of the equation. So 1 minus 3 is negative 2, and this is just my check step. Is that equal to 2 minus 4 times 1? So 2 minus 4 is negative 2. Negative 2 is equal to negative 2, and that proves that it's correct. So this right here is just the check step. I mean, why wouldn't you check it? But we'll call it optional. Okay. Which of these have the same solution as equation 1? So I'm just going to work my way through each of these and describe the process as I go. Alright, drawing this line to remind myself to do the same thing on each side of the equations. I'm going to move the variables to one side of the equation by doing the inverse. This is 0. That leaves me with 10x minus 6 equals 4. I'm going to add 6 to each side. 10x is 10. Divide each side by 10, and x is 1. Let me write that larger. Okay, so this has the same solution. I think I'll write the next one over here and give myself some room. Okay, x minus 5 equals negative 4x. So again, I'm going to try to get my variables on one side of the equation. I think this time I'll just go ahead and subtract x, and that cancels, so I get negative 5 equals negative 5x. So this time I moved my variables to the right side of the equation, which is fine. Some people aren't comfortable with that, but it's really okay. Negative 5 divided by negative 5 is 1. Negative 5 divided by negative 5 is 1. So 1 equals 1x, or just 1 equals x. If you feel more comfortable, you could say x equals 1. But you do need to realize these are the same thing. Alright, let's move on to the next equation. Let's get my paper just a smidge. There we go. Now this time, I've got a choice to make because I do have a 2 times the quantity inside the parentheses. So I can either divide each side by 2 to start with, or I can distribute to start with, but I need to do one or the other. When I look over here and think about dividing by 2, I'm going to end up with some fractions, which is okay, but I really don't want to do that right now. So I think I'll distribute first, which is going, and I'm going to write that one up here, just giving myself some room. 2 minus 4x equals x minus 3. Drawing my line as a reminder to do the same thing on each side of the equation. want to move my variables to one side of the equation. I think I'll move them over here on the left. I usually do that, but sometimes I don't. I try to make a point to show you that it's okay to put the variables on the right as well. At any rate, 2 minus 5x equals negative 3. Now I'm going to need to move this 2, this constant, to the other side of the equation. So I'll do the opposite of what's currently happening with the 2. Since that's a positive 2, I'll do a negative 2 or minus 2. So negative 5x equals negative 5. Divide by negative 5. X equals 1. Oh, well, that's the same as what we started with. So I'll write same. And the one I did before was also the same. That's really interesting because these look totally different than the one up there. Okay, one more to go on this page. Go back to red. All right. So I'm just going to leave this variable on the right side, and I will move the constant to the other side of the equation. Negative 5 equals negative 5x. Divide each side by negative 5. 1, 1. I'm not just marking that out. That's a 1. All right. So 1 equals x, or x equals 1 if you prefer. Same thing. All right. Oh, this is the same as all of the others, which was interesting. All right. We're ready for the next page. Okay, here's an equation and all the steps Claire wrote to solve it. Here's the same equation and the steps Lynn wrote to solve it. Are both correct? Explain your reasoning and describe some ways they look alike or different. Okay, so let's just look at this with a critical eye. It looks like they've combined this to get 12x, then the plus 3. No change over there yet. Okay. Then they have factored out a 3. And we did that when we were doing expressions. So they factored out a 3. 3 times 4x is 12x. 3 times 1 is 3. So that's correct. Okay. And then they've divided each side by 3. Which gives me 4x plus 1 equals 5x plus 9. So far, so good. Okay, then it looks like they've subtracted 4x from each side. So that would leave 1 here, and 5x minus 4x is x, plus 9. Okay, then they've subtracted 9 and subtracted 9. So this is correct. Everything there is correct. So let's make some notes. Here they combined like terms. Then here they factored out a 3. And then they multiplied by 1/3, which we know that's dividing by 3. And then they've subtracted 9. And every time they did it to both sides, which is important. It's required. Okay, and then this is correct. So that's how Claire was thinking about it. Let's see how Lynn was thinking about it. Okay, you took that same first step. Good. Now he didn't factor. Instead, he subtracted 3 from each side right here. Okay, they combined like terms up here. Oh, then they distributed. And subtracted 3 from each side. Let's make sure the distribution was correct. 3 times 5x is 15x. 3 times 9 is 27. Okay. 15x plus 24. That's when we subtracted the 3. Alright. Then what did we do? Subtracted 15x. Left me with 24. Subtracted 15x. Left me with negative 3x. Divide by negative 3, or multiply by negative 1/3. Okay, so this is also correct. So, these are both correct. Are they both correct? Yes. And describe some ways they look alike or different. I'm just going to draw an arrow up there because I think that we have described it as we went. Like here, this is 1 point of difference. Okay, and this line here is very different actually because of the factoring versus the distributing. But interesting to see that even though Claire and Lynn thought about this problem differently, they did end up with the same solution, and both of them were correct. So let's move on to the next page. Looking at my time, I believe I'm just gonna kind of show this. Well, we'll do another video if we need to. Okay, Maya and Noah solve this equation, but some of their steps have errors. Find the incorrect step in each solution and explain why it's incorrect. Okay, so we're good with the 12. 3, that's all good. Now here, they ended up with 7x. So I'm thinking that came from 12x minus 5x. Okay, this is not 5x. This is actually, that is 15 x's. It's 3 groups of 5 x's, which is 15 x's. So this is right here, this is the incorrect part of that. Okay, now let's see about Noah. So he did distributing here. 3 times 9 is 27. 3 times 5x is 15x. Okay, this is good. This is good. Now here we've got 27x. So 12x plus 15x equals 27x. Okay, but what should have happened was we should have subtracted the 15x. Okay, should have subtracted 15x to move the term to the other side of the equation. Okay. And this is teacher work, y'all. This is what we do all the time to try to figure out what mistakes have been made and how that we can help you all fix them. So it's good for you to look at this as well. It's a different kind of thinking than maybe you're used to, and it's a good thing to do to find the mistakes. Okay, I think I'm going to stop this video here, and then I will pick up with the next problem on the next video.